Hi everyone. So as we discussed last week, one of the most important things, possibly the most important thing about doing data journalism is providing context for the information that we present to readers and that we use to conduct our own analyses, right? So if we want to understand what's happening with a particular phenomenon, we not only need to get the data, we need to vet the data, make sure that we understand any limitations or biases in its collection. We trust the data source, that we're accounting for any limitations or errors that it may have, but we need to provide context, okay? And as we discussed, without context, a number is just a number, right? And especially these days when there's kind of this feeling that, anybody can make up their own facts and everybody has data to support their argument, applying appropriate and rigorous ways to determine these sort of internal context for data is really important. Most of the time we're going to be using very basic analytical methods to do this, but hopefully what this will show you is that A, there are appropriate kinds of analysis to do, and B, it helps us be consistent and meaningful in the way that we present that data. Now, for starters, we're going to be working with CitiBikeData. So I know that for some of you, you had a transportation beat earlier this semester. This isn't a requirement. You're not required to use this data for your final project, but it gives us a jumping off point to work on this together. So the first thing I'm going to point out, this is actually the City Bike system for New York. There is a related actually open source data set that shows up as City Bikes, and it is, let's see, City Bike data open source. Where is it? Here we are. So this is actually not City Bikes as in Citibank City Bikes, but this is actually a City Bikes API that pulls in data from a bunch of different systems, including things like Washington, D.C. and a few around the world. And so there's actually one that we can see here. This is just showing you kind of where they have data for, which is pretty exciting, actually. So we're going to work with the New York City City Bikes, as in the branded City Bikes data. But it's pretty neat to kind of look at this map, gives you a sense of how much activity there is around the world using bike shares in various regions. And I think we're going to find this a fun data set for us to work with for our data exercises in this class. So to get down to it, one of the things I want to point out, we're not going to be using this right away, is that there is real-time data available from this. And so if we look at this, if I click on this link, I hope that you all recognize this data format. It's, as it often is in this case, not wonderfully formatted, but if I were to copy that out and pop it in here, whoops, get our copy going here, hopefully that worked. Okay, see it comes out on one line, and what do you know? It's JSON. Okay, so we're going to talk a little bit about what some of this stuff means, but again, what you see here is we have a last updated. This is a timestamp in seconds from January 1st, 1970. We'll talk about why that's the case. The TTL, there's actually a description of this in the metadata about this, but TTL is short for time to live. And 10 is the number of seconds, so it's basically saying this data will be outdated in 10 seconds. It gets updated every 10 seconds. A general object called data, EN, probably an abbreviation for English, and here are the feeds that are available. And I can go ahead, you'll see that they follow the same format that you all worked on this past week. And if I go here, what I get is the station status, and we see, again, a very nice effort to have these be descriptive names, so I have a sense of what this data is about, even though I don't have any other metadata or description of it. How many bikes are disabled, how many docks are available, how many docks are not functioning, all of this stuff. The last reported, that's going to be the last time that station reported data in. And this, gives the station ID. We'll see how that becomes meaningful in a minute. So anyhow, we're going to move on to this later in the semester, but for now we want to just look at some of the historical data and use that to do some of our arithmetic calculations and understand how these can give us a sense of scope for a particular data set. So rather than focusing on that, we're actually going to look at bike trip history data, which comes as a set of zip files. And if I go through here, if I go all the way down, I can see that I've got a 60 megabyte zip file that looks from its data format to be 210609. So I'm going to guess that that's September 2016. I'm going to go ahead and download that file and then unzip it on my desktop. And we're going to take a look at this and see what we get. So if I double click this, it's going to expand. And we'll see that this is actually pretty efficiently compressed. This is about a 60 megabyte zip file that decompresses to a, let's go to, well, I never remember how to do this. If we look at this, it is, I believe, about 300 megabytes of data. Oh, that's not going to work. We're not going to do that. It's a pretty large file. I believe it's about 300 megabytes once it's opened. Now, we notice that this is a .csv file, and it's a .csv file because it's a very large data file. And as we discussed, a CSV file is kind of has the least, what we sometimes say in programming, cruft, right? Which is extra stuff that's associated with a particular program. So while we can obviously open this in something like Microsoft Excel, if this were a Microsoft Excel file, it would be much, much larger, and it's already a pretty big data file. So just to demonstrate that this is actually a text file, I'm going to go ahead and open it in TextEdit and see how we do here. Now, as I said, it's still 300 megabytes, so it's still going to take a minute probably to open, but we can see right away that if we just, on inspection here, right, if we just kind of look at it, we can see, okay, we have column headers, trip duration, start time, stop time, start station ID, start station name, latitude, longitude, and station ID, right? So this is kind of hard to read, but we can see that there are commas in here. And then we start to get into our data. We notice that there's quotes around everything. We'll talk about that in a minute as well. We see we have bike ID, user type, birth year, gender, which is kind of interesting that they're collecting that data. So we could possibly do, analysis on that if we wanted to. But basically, just demonstrating here that I can, even though it's a really large file, I can open it pretty quickly in TextEdit. Now, I'm going to try to open this, because I want to do some math on this, I'm going to open this in Excel. Now, we could use Excel, we could use LibreOffice, we could use OpenOffice. There are a bunch of different programs out there. What you'll find is that they all support the same functions that we're going to use here. They may execute them slightly differently. Obviously, the layout of the software will be somewhat different. But the mechanics of it are going to be fundamentally the same. So to do this, I'm going to do Open With again here, and I'm going to choose Microsoft Excel. And now we're going to wait. And the reason why we're going to wait is because this is a pretty large file. So I was expecting it to actually take a little bit longer to open with TextEdit, but it was pretty fast, I thought. And again, I'm not going to be able to do any analysis with TextEdit, but I can at least kind of see what's in the data, right? I can read the column headers, get a look at some of the lines of data. And especially when you're dealing with large data files, this is usually your best first option. Because you don't know what you're going to get when you try to open it with something like Microsoft Excel. So you can see this is actually taking quite a while. I have no idea how many rows are in this. In fact, if you were here with me, I don't think you can hear it on the video. My computer is starting to strain a little bit on the size of this file. Oh, I've got the beach ball showing up, which for Mac users will be familiar as a sign of effort on the part of the computer. And we wait, and we wait. And with any luck, this will open. Aha, this is interesting. Okay, so file not loaded completely. So here's another challenge of working with Microsoft Excel. We noticed that TextEdit opened this actually quite quickly, no problems. Excel can't actually load the entire file. This is a not uncommon problem when dealing with large data sets. So what I'm going to do here is we will notice that if I were to go all the way down to the bottom of this, you can see the row number in the at the left-hand side here. If I just sort of zip all the way down here, I believe this is, am I counting correctly here? We have over 1 million rows. I think that's 1 million rows. And if we look at the dates, what we'll see is we've gotten about 3 weeks into the month, okay? My first the timestamps on my first data points here are midnight on September 1st. And so over a million rows is about 3 weeks of data for CitiBike. It's a big data set. So for our exercises today, we're going to work with a subset of this, understandably, and we're going to use the station IDs as a means to kind of look for patterns. But I just want to point out in this moment that it's a non-trivial difference, right? It really makes a difference working with a CSV file instead of an XLS file. Also the ability to open it with TextEdit, right? I can preview data that way. So first stop for you when you get a new CSV file, particularly if it's large and you don't know what's in it, I strongly recommend that you begin by looking at it in TextEdit or Notepad if you're on a PC, just to get a feel for what's in there. So what I'm going to do here is I'm going to actually create an edited version of this file. I'm going to take us down to about 10,000 rows, just 10,000 rows, to do our beginning analysis. And so when we come back, we're going to be looking at some of the arithmetic ways that we can look for patterns and distributions, right? So basically what we're going to be looking at is measures of central tendency. That's our mean and median. And we're going to be looking at, and then measures of spread, right? How spread out are the values across the possible, across the data set. And again, the whole point of this is that it gives us a way to say what is kind of expected and what is unexpected. Because one of my favorite things is that you can't really mathematically say, what outliers are, but we can make an assessment about what kinds of data points are genuinely extreme and what are expected on the basis of these kinds of calculations. So I will see you all back here in a minute, and we will get going on our analysis.